This is the OR question of question number 34. It says there are two identical solid cubical boxes of side 7 cm. From the top face of first cube, a hemisphere of diameter equal to the side of the cube is scooped out. This hemisphere is inverted and placed on the top of second cube's surface to form a dome. Find, first part, the ratio of total surface area of the two new solids formed. Part second, volume of each new solid formed. So this is the diagram of both the cases. Here the side of the cube is given to us. Let's try solving first part first of all. So side of cube is given to us as 7 cm. And since the diameter of the hemisphere is equal to the side of the cube, we can write down diameter of hemisphere D is equal to 7 cm. So what would be radius? Radius of hemisphere will be half of the diameter, which is 7/2 centimeter. So to find out the surface area of the first solid which is formed after scooping out the hemisphere from inside, we are going to get, let us name it as S1, is equal to total surface area of the cube, which is 6a square, where a represents the side of the cube, plus curved surface area of hemisphere, which is 2 pi r square, minus the area of the circular portion, which is pi r square. Now this is going to give us 6a square, 2 pi r square minus pi r square would be pi r square. Now substituting the values, we will write down 6 into a, side of the cube is 7, so therefore 7 into 7, that is a square, plus pi, which is 22/7, into r square, so that is 7/2 into 7/2, which is equal to 294 plus 2 ones are and 2 11s are, 7 ones are and 7 ones are. So 11 into 7, that is 77, divided by 2. This is going to give us 294 plus 77 upon 2, which is equal to 38.5. So on adding this, we are going to get 332.5 centimeter square. Surface area of the second solid formed, which is what we get after inverting the hemisphere and placing it on the top of the second cube surface to form a dome. This surface area, let's assume it as S2, it will be equal to the total surface area of the cube, which is 6a square, plus here also we will include the curved surface area of hemisphere, which is 2 pi r square, minus the area of the circular base, which is pi r square. So this is going to lead us to 6a square plus 2 pi r square minus pi r square is pi r square. So observe, since the quantities are same, here also the side of the cube is 7 cm and the radius of the hemisphere is 7/2 cm. For this surface area also, we are going to get the answer as 332.5 centimeter square as the surface area after simplifying this further, right? So we have to find out in the first part the ratio of the total surface area of this two new solids formed. So let's write down, ratio will be equal to S1 divided by S2, which is equal to 332.5 centimeter square divided by 332.5 centimeter square, which is equal to 1/1. So therefore 1:1 is the ratio. In the second subpart, they are asking us the volume of each new solid formed. So in the first case, observe volume of solid. In the first case, let's represent it with V1, which is equal to volume of the cube, which is A cube, minus volume of hemisphere, which is 2 upon 3 pi r cube. Why we are subtracting here? Because the hemisphere is scooped out, right? That's why. Now, substituting the values, we are going to get A is 7, side of the cube is 7. So, 7 cube minus 2 upon 3 into pi, that is 22 by 7, into r cube. So, that is 7 by 2 into 7 by 2 into 7 by 2. So, 7 cube, that is 343, minus, simplifying this entire value, 7 ones are 7, 7 ones are 7, 2 ones are 2 ones are 2 ones are, and this would be 2 11s are. So, 11 into 49 divided by 6. This is what we are going to get, right? So, 11 into 7 would be 49 divided by 3 into 2, that is 6, which is equal to 343 minus 11 into 49, that is 539 divided by 6. Now, taking LCM as 6, we are going to get 343 multiplied with 6 will be 2058 minus 539. This is what we have to do, right? So, on subtracting it, we will be getting 1519 divided by 6 centimeter cube. This is the volume of first solid which is formed. Now we will find out the volume of the second solid, which is formed on placing the hemisphere by inverting it on the top of the second cube, right? So we will get volume of the second solid. Let's represent it with V2 equal to volume of the cube, which is A cube, plus here the volume of hemisphere will get added. So 2 upon 3 pi r cube, right? Because you are placing the hemisphere on the top of the cube. Let's substitute the values. Here A cube would be 7 whole cube plus 2 by 3 into 22 by 7 into r cube, that is 7 by 2 into 7 by 2 into 7 by 2. So 7 cube is 343, and on simplifying this entire value from the above, I am writing it as 539 divided by 6. So this will be equal to, on taking 6 as the LCM, we are going to get 2058 plus 539 divided by 6 equal to 2597 divided by 6 centimeter cube. So this is the volume of each new solid which is formed after scooping out the hemisphere as well as after placing the hemisphere on inverting it on the top of the second cube. So this is the solution of the second subpart of question number 34.